Today we're going to unbox a couple of things. The lifters came in, the ball hone came in, so we're going to do a little bit of work on the block. Going to show you a little bit about grinding the valves. I got the valves cleaned up, got them ready. We had a disaster with the valves. Pretty much all of them were shot. So we'll talk about that here in a second. But looking for good quality lifters. Not all lifters are made the same. There's a few companies that I think actually do a better job than anybody else. Crower and Iski are the two brands that you know that you can go to, and you're going to get a good product from them. So so I'm going to have these on a pretty good price break. So pick them up, and that'll be nice. Let me see if we can pop this box open for you without tearing everything up. There we go. So you got these basic flat tappet hydraulic lifters. Here is the groove that rides in the block. It rides about like so. And then the oil groove will match up with this, so when it's neutral, resting on the base of the cam, it will oil in that hole through this groove, go up the push rod, and oil the rocker arms and the pivot ball and the nose that rides over the valve. And then as it goes up or down, it will get out of that oil groove in the block. But that channel in the block will match this, and of course it stays sealed 100% of the time. So good quality part there. And we'll be setting up later on about push rod length and all those good things. Then here, if this is what the tracking said it was, will be the hone. Different tools, different jobs. And there we have it. This is a flex hone. It's what they call a ball hone. Now what the deal is with this, when you're doing a re-ring job, is different than when you're doing bore and hone for sides. Machine shop, they use stones to get their bore set, but when you're doing a re-ring job, you really don't want to be aggressive about taking a lot of metal out of that bore when it's a re-ring job for several reasons. One is that bore has shaped over time to the stresses of where the engine runs, and it's about as round as you're going to get for the situation you have. And if you start changing that, then you're just going to have a worse situation about sealing your rings up. Plus, it's already somewhat loose because it's had 50, 75,000, 100,000 miles of wear. Now you're taking more metal out, so that's going to make it even looser. So the ball hone is what some people call the bottle brush. Is a very good and effective tool. So what you do here, you got to buy it for the right size of the cylinder bore, and then lube it up. You want to put some 1030 or automatic transmission fluid or some kind of fluid in there to lube up these balls, because they're somewhat porous. They're a silicone oxide that is abrasive to a point. And of course, like we talked about before, you want to get the right type of grit. This is a 320 grit, which is good for molly rings. And then it's a 4 to 4 1/4, and we're 4.040. And so we're good to go there. So we will stick this and let it soak in a little bit of oil, because when you first put in that cylinder bore, you don't need it soaking up all of the oil off of the cylinder. You want that oil to help wash out the honing that you're doing. It doesn't take a lot of metal off at a time, but it will take some metal off. So you do want to treat it with respect, and we will go over more about honing here in a minute. All right, now got a couple other things here. I believe the camshaft came in. We'll take a look at that. and the timing chain. So we'll get to going together on that block and the heads this week. We'll get some progress done and show you how to finish up this job, how to degree the cam in, and be good to go. Like we talked about, for this particular job, we are employing the use of a comp cam. It's a 31-215-2, which is a 252 degree duration high energy cam. It's an older style cam, but it works well. It's easy on valve train. Got some good bottom end torque. It's 206 degrees 050 on intake and exhaust, and it's a 0.433 lift, not quite a ½ inch. But I've run one before and it works extremely well on a pickup. So I think it's going to do a good job for us for what we're doing here. And then let's get to the timing chain. This is a timing chain that came from FordStrokers.com, and the Woods family runs the Ford Strokers. They do a great job. They're good people. They only sell quality parts. You're safe when you deal with the Woods family there, so I would recommend them as a resource for parts. As far as I know, they've got the best timing chain on the market. They run a German chain. Some of the other chains that are available that come in these timing sets that you get from the big box stores are not the quality of this set, because they spec'd out this set. This is, you can only get it from them, and and this is kind of a deal, you get what you pay for. So this set costs 120 bucks plus shipping, but you have a good quality German chain. And let's unpack it here a little bit. You can degree it. It's got a lot of options for degreeing. And it also has been machined with a thrust washer on the back. And so you have to make sure that this thrust washer lines up with your flex plate. And we've got 2 screws that have been machined for this. They come with a package for that purpose. You can see they have a taper there so that they sit flush or just below the retainer plate, so that this bearing surface does not rub on those retaining screws. So we'll show you how to set that up when we get to that point. You can see in here we've got lots of timing options. And you'd be surprised. Last motor, like I said, that Mustang motor there, the Mustang right there, we put it together, wound up using a little bit more of those chain events, wound up using a little bit of what I guess I'd say the outer limits there to get everything lined up where it belonged, because the timing, the keyway in the crankshaft was a little bit off of spec. And so when we lined up the cam and got it on degree, we were at the limits of what this chain would do. If I'd had a different chain, I couldn't have put it into spec, because that crankshaft keyway was off a little bit. So having your options pays off. All right, so the next thing we're going to do, talk about the valve grinding, my valve grinding fiasco. So what I did was I had these dirty, junky old valves. Remember now, this, let's see, yeah, this is the one. Remember the one that was slightly burnt? There's that burnt edge. You can see it's got a little scallop right there that is burning its way in. It had not lost everything yet, but it was working its way in. You can see all that crud. Well, necessity is a mother invention. This is what I use to clean up the valves. I this way, then flip it over and clean it off this way. Got all the valves clean. Now, for a second here, let's stop and talk. Why did this valve start to burn? because this edge right here, that edge right there on top there, that's called a margin. That margin, if it's too thin, will lead to the valve burning because it cannot dissipate heat. And these valves are welded on to the shafts in the assembly process. They spin them onto each other under high pressure and fast RPM, and they weld themselves. Well, that head is not always totally concentric. And so when you grind it, you have to look for the thinnest spot. And then at that thinnest spot, you look and see, is it thick enough to dissipate the heat? And 6 out of 8 of my intake valves were too thin to dissipate the heat. 4 of my exhaust valves were too thin to dissipate the heat. We're going to take this valve here and show you how to grind, but this one's going to turn out too thin also. See that margin there? That is already at the minimum. 80 thousandths minimum for exhaust, 50 thousandths minimum for the intake. So there's no use putting some work into a valve job and then just having it burn down the road, because then you got to pull it all back apart, put some new parts in, and you got yourself a mess. Here's an old KOE valve grinder. I bought this back in 1980 when I was 20 years old, and believe it or not, loaded it up in the back of my 1969 Roadrunner. Had a 69 rotor with a 383 and a 4-speed, and later on put a 440 in it, and it's a pretty fast little car. But anyway, we loaded that valve grinder up in the back of that 69 Roadrunner and drove off. Bought it for 200 bucks back in the day. I have ground a lot of valves. It has paid for itself. So here we go. So what we do, there's a setting right over here about what degree we want. So we put the peg in over there at 45 degrees. This is nice and surface smooth. It's it'll kind of kick on here, and it's got there it goes, up to speed. Oil comes out of here to cool and lubricate that valve while we grind it. We're not going to worry about that oil catching up speed because this is junk anyway. Set your valve in here. You tighten your handle over here, flip it on. You can see that spin. Now we're going to come over here and we're going to crank this handle here, runs it on in to where we can start to grind the valve. So now when we get close, we'll slow it down a little bit so we don't just jam that valve into the wheel. See it go? See that difference there? Get a little bit out of hand there. We go back in, whoops. That old valve, they can grind, you know, they get a little bit of a surface on that valve that's not quite right, and boy, she'll jump around a little. Let me see what's going on here. It's not supposed to be jumping like that, and it certainly is. Let's come back over here on this side and see if it'll, there we go. Kind of get it trued up a little bit, and then we can grind it. I think my wheel's not as true as I thought. Oh, anyway, you get the idea there. I was using that wheel a couple nights ago and it was trued up just fine. So I don't know if it's a temperature change, but something happened there. We're going to have to true that wheel again. So you can see that it's all concentric. Not the best job, and I wouldn't run this. I would true up the wheel and grind it again, but this was just a demonstration purpose. And so you can kind of see what's going on there and how that works. The truing tool will bolt in here. It comes across here with a diamond point, and then you simply run this in and out while it brings that diamond point across the wheel and trues it back up. That wheel's just a smidgen off now. Like I say, it was grinding fine a couple nights ago. The temperature change must have done something. Oh, anyway, that's That's only for demonstration purpose because we got the 4 valves here. These 4 valves here, we got them all ground, and they are nice and smooth and concentric. They've got a reasonable margin on them. And then we got ordered 4 new valves. The valves were a little hard to find, so I got them off eBay. Some new old stock. You can see there, that one's got a nice margin on it. They're all within reason. So we'll run them, and we'll get that head put together. So the next thing we're going to do is work on these lifter bores. Remember, we're running a flat tappet cam. Here's how, if you look down in here, well, it's a little hard to see. Let me see if I can rotate it over into some light. You can see right there, that's where those oil holes are that lifter runs in. This galley here, those holes go in between on that galley, and the lifter's right in that bore. Well, the motor is a clockwise rotation, so we're wanting to put some oil onto the camshaft on this side of the lifter bore and on this side of the lifter bore. So we're going to take this 3-point file, and we're going to file a groove from where that lifter rides with even with the galley, and we're going to groove it a small amount down to the bottom of that bore so that there'll be a small stream of oil spraying onto the camshaft lobes as the motor runs. Like we said, that is a modification that was developed by some pretty sharp creative mechanic in NASCAR. They have to run flat tappets because of their rule restrictions, and they run really high RPMs. They run 10,000 RPMs on some of those motors, and they'll run them for 500, 600 miles, and grueling conditions, and flat tappet cams with high spring pressures, and they have to last.